Welcome back, everybody. And we are talking about solutions, and we are about to finish this unit. We've talked about all the basics of solutions, right? We've talked about definition and what makes up a solution and the process and types of solutions, types of solute and factors of solubility. And last time we talked about molarity, which is a way of quantifying the amount of solute in the solvent. Now, let's go to something else that I really like, and you all will like it too. In fact, it's something very familiar and close to our hearts, and that is stoichiometry, right? But this is solution stoichiometry, and there's really nothing difficult about it. Remember, in stoichiometry, we can go from anywhere to anywhere using mole ratio, right? So I can go from any component to any component in a balanced, in a reaction using a mole ratio, and that mole ratio comes from the coefficients, right, in my balanced equation. But to use that, we have to get moles, right? So with solution stoichiometry now, since I know molarity is equal to moles of my solute per liter of solution, if they give me molarity and liters, then I can calculate moles. And once I have moles, I can use my mole ratio to go anywhere. So that is what we're going to do. And I think the best thing to do is not give you any more notes, but rather let's work one. Here we go. I've got 12.5 grams of solid magnesium. It's reacting with a 0.100 molar solution of hydrochloric acid. What do we need to know? How many milliliters of this hydrochloric acid are required? And the first step is always going to be write my balanced equation. So I have magnesium, and it is solid, and it is reacting with a solution of hydrochloric acid, and it's going to form, hey, what is this? This is a single replacement reaction. I'm going to form magnesium chloride, which is aqueous, plus hydrogen gas, right? We can remember that. Good. Now we need to balance that. So I need 2 of those. So now it's balanced. Now we're going to work this like any other stoichiometric problem. I start off with 3.5 grams of magnesium, 12.5 grams of magnesium. So what do I need to do with that magnesium? I need to make it into moles of magnesium. So moles of magnesium are equal to 12.5 grams times 1 mole per what? What's my magnesium? Magnesium is, let's get rid of this yellow spot here. Good. Magnesium is 24.31. So 24.31 grams. And what do I get? 12.5 divided by 24.31, and it looks to me like I get 0.5141 moles of magnesium. Good. So then what do I need to know? I need to know something about hydrochloric acid. So how do I go from magnesium to hydrochloric acid? Well, I can get moles of hydrochloric acid by taking my moles of magnesium times what? Well, the mole ratio. What's the mole ratio between magnesium and hydrochloric acid? Well, I have 2 moles of hydrochloric acid for every 1 mole of magnesium. So then that would mean I take that number, multiply it by 2, and I have 1.028 moles of hydrochloric acid, right? Cool. But I don't want moles of hydrochloric acid. I want a volume of hydrochloric acid. And I also have a molarity, right? Here's my molarity. Ooh, I have molarity. So molarity is equal to moles of my solute per liter of solution. What is it that I want to find? I want to find liters of solution. I have my moles of solute, and I have my molarity. So let's work this out. Liters of solution then will equal what? Moles of solute per molarity. So if you're a memorizing kind of person, you can memorize that. Liters equal moles of solute divided by molarity. If not, you can just work out the algebra or manipulate the equations, what I like to do. So here's the way I'm going to work it. I go back up here and I have 0.100 molar, 0.100 molar, and that's going to be equal to 1.028 moles of hydrochloric acid divided by liters of my solution, and that means liters of my HCl aqueous, right? Multiply both sides by liters of HCl, and then divide by my 0.1, so liters of HCl equals 1.028 moles of HCl divided by 0.100 molar, and that gives me 10.28 liters of HCl. But do I want liters of HCl? No, I want what? And how many milliliters of HCl? How many milliliters of HCl? Holy moly. That means I have to multiply that by That means I have to multiply that by 1,000. 10.28 liters times 1,000 milliliters per liter. And what do I get when I take that? I get, wow, that's a whole bunch. We want how many sig figs? I think I want 3 sig figs. 300 milliliters. Whoa, mamma mia. 10,300 milliliters of HCl. Okay, cool. Make sense? I think it does. Cool. Now you guys try the next one. Bring me back when you're ready. Well, first thing we're going to do is write our balanced equation. Sodium reacts with silver nitrate. What kind of a reaction is this? Well, it's going to be single replacement. So I'm going to make sodium nitrate plus silver. That's going to be solid. That's going to be aqueous. Good. I have 1.72 grams of sodium. So what's the first thing I want to do? I want to figure out moles, or second thing. First thing is write that balanced equation. I need moles of my sodium. Moles of sodium. Where's sodium? 22.99. 22.99. So that is 1 mole per 22.99 grams. So we're going to take 1.72 divided by 22.99 equals 0.07481 moles of sodium. Okay, and we want to figure out how many milliliters of silver nitrate are required. Okay, so that means before I get volume, I have to figure out moles of my silver nitrate. So moles of my silver nitrate equals 0.07481 moles of sodium times, what's my mole ratio? Looks like 1 to 1. Perfect. 1 mole of silver nitrate per 1 mole of sodium. And what does that give me? 0.07481 moles of silver nitrate. And I have a molarity, right? And we said that liters of my solution equal moles of my solute over molarity. Got it? So I plug that in. I get liters equal to moles, 0.07481 moles of silver nitrate over the molarity of my silver nitrate. What's my molarity? 0.175. 0.175 molar. And what do I get? Divide by 0.175. Looks to me like I get 0.4275. So that would round to 0.428. What is that? Liters, but we want milliliters. So I take 0.428 liters times 1,000 milliliters per liter, and I get 428 milliliters of silver nitrate are required to react with 1.72 grams of sodium. Beautiful. Are there any questions here? Okay, let's check out the time. I'll tell you what, let's make this a short one, and then we'll finish off next time with a longer one. Okay, this is solution stoichiometry, and next time we'll talk about neutralization and dilution. Ciao.